This lesson is all about ellipses. An ellipse is the set of points in a plane such that the sum of the distances from two focal points is constant. And that's probably a little bit more difficult to imagine than with the circles or the parabolas even, so let's go ahead and jump into an applet to really show you what that means. Here I have a setup where I've got two focal points labeled F1 and F2. A is a vertex of the ellipse, and we'll discuss that in a bit, but it's an important point to describe it as well. P is a point that actually exists on the ellipse, and if you'll notice up in the corner, I have an equation here taking the distance from P to the first focal point and to the second focal point and adding those together. Because what that rule we just looked at said was the sum of those distances is always constant. So the distance itself will always change, but the sum will stay the same. So as I move P to make the shape of an ellipse, notice how the distances between P and the focal points changes, but the sum of those distances remains constant. And that's one of the properties of an ellipse. And you can change the location of focal points, the relationship between the focal point and the vertex. You'll always get the same relationship between the distances of P to the focal points. If you change the location of the focal points, you basically just change the size of the ellipse and the orientation. If you change the point A, you change basically how round or flat the ellipse is going to be. But all of these still have the property that the sum of every single point on the ellipse to each of the focal points is a constant distance. Now let's look at the parts of an ellipse that are important to know and understand. So here's a basic ellipse. The center point is important, and we will always give the center the coordinates HK, and that's consistent with how we did circles and parabolas as well. The ellipse is always going to be stretched out on one axis more than on the other. Now this doesn't have to be a horizontal and vertical axis only. These ellipses can be tilted, but we're not going to consider those. We're only going to consider in this class ellipses that are on the horizontal and vertical axes. Now, as I was saying, the ellipse is always going to be stretched out among one axis more than the other. The one that it's stretched out more on is called the major axis. So the major axis, I'll write it out here. In this case is the horizontal axis. So basically the major axis starts here and goes all the way to the other side of the ellipse. Now these 2 points that I've put in green, these are called the vertices. So you could call this vertex 1 and vertex 2 if you like, although there's no real ordering to them. It's just there's 2 different ones. And the vertices are always located on the ends of the major axis. In contrast, we also have a minor axis. And so the minor axis goes this way. The minor axis is always going to be shorter than the major axis for an ellipse. Now, there are some special distances that are useful to know. So the distance from the center to the end point of, to one of the vertices, or the end point of the major axis, we call that distance A, lowercase a. And it's going to be the same on both sides. So I could have gone from the center to what I've called V1, and that would be the distance A as well. And along the minor axis, this distance is lowercase b. Now, we've mentioned focal points in our definition of an ellipse. So the focal points, in this case, maybe they're right here and right here. I'll label this F1 and F2, although again, I'm not trying to put a specific order to them, I'm just saying there's two different focal points. But they are both the same distance away from the center, which is lowercase c. And what would be nice is if the relationship between these distances, A, B, and C, is that they would be the, sides of a triangle that would form a Pythagorean identity. It turns out it's almost that way, but not quite. The relationship between these variables is c squared equals a squared minus b squared. And one thing to note here, a is always the distance along the major axis, so a is always greater than b. So that's important because if you're doing a squared minus b squared, if b is larger, you end up with a negative number, which results in complex values, and that's no good. We'd like to avoid that. So those are all the important parts of our ellipse. The equation of an ellipse, let me show you what that looks like. It looks like this: x minus h quantity squared over a squared and y minus k quantity squared over b squared equals 1. So h and k is the location of the center. So it's very similar to the equation of a circle in that respect. A squared and b squared, those are basically going to give you the distances along the major axis and the minor axis. But one thing to kind of note is these will actually be numbers when you see a formula. So you might see like 25 and 16 perhaps. It's the larger of the two numbers that is the value a. So I've put a underneath the x, but it's just as likely you might run into an equation where we have like x minus h quantity squared plus y minus k quantity squared, and then we have the shorter value under the y. And what that does is it changes the location of the major axis and the minor axis. So the second one, the one that was originally here, this has my major axis horizontal. And then this one has my major axis vertical. It's much easier to depict all this from the formula because you're actually just working with numbers and not variables. So it's just, the rule is whichever number is largest, that's the one that's a, and that's what we use for the major axis. All right, so let's do some examples. And the first one is to identify the location of the center, vertices, foci, and links of the major and minor axes. Afterward, provide a sketch of the ellipse. So we'll start with, just getting our hands wet. The center is going to be relatively easy. The way that the formula presents the center, it's the h and k, so the numbers, connected to x and y. But just remember, in the formula, it's x minus h and y minus k, so we take the opposite of these values. So -4, -2 for the location of the center. And we're going to provide a sketch in the end, so there's no reason we can't go ahead and start there. So -4 on the x, -2 on the y, there's my center. Now, between the numbers that are under the x and the y parts, the 9 is the largest. So that's going to be my a squared. So it's always the larger of the two that's defined as a, and that's going to be the length of the major axis. So what I can deduce here is that the major axis is vertical, because that larger number is under the y, which is the vertical variable. That's the way I go about remembering it. Now, if a squared equals 9, that means that a is equal to 3. And then if b squared is 4, then that means b is equal to 2. So using those, I can find the endpoints of my major and minor axes. So let's do that. One thing to note is each tick mark on this scale is only worth half a unit. So if you see me jumping 2 units at a time, that's the reason why. So from the center, I'm going to go up and down 3 units. So 1, 2, 3. So there's one of my vertices. And I'm going to go down 3 units from the center. So 1, 2, 3. And there's the other vertex. And remember, the vertices are only along the major axis. I'm not sure why they don't refer to the vertices or the endpoints of the minor axis also as vertices. I have an idea as to why that's the case, but you know, that's just the standard rule, is that the vertices are only on the endpoints of the major axis. So going from the center 2 units left and right, so 1, 2, and 1, 2 this way, there's the other endpoints of my ellipse. Now at this point, I could go ahead and sketch the ellipse. That would be no problem. And I generally do it in kind of in 4 parts, just to get the shape of the ellipse as close to what it should look like, you know, as possible. Circles are hard enough, ellipses are that much more trouble. Now, it did ask for the location of the vertices, so I'll go ahead and describe the vertices. Since I've already drawn the ellipse, I could just derive the vertices directly from the chart. So like for instance, this point is -4 on the x, 1 on the y. This point down here is -4 on the x and -5 on the y. There's my vertices. So you could derive them that way, or you could just use the value of a along with the center, and note that the x is not going to change because you're moving up and down from your center. And you'd start from -2 and then go up or down 3, which is the value of a. All right, so that would result in -4. Then if I do -2 plus 3, that's 1. And if I do -2 minus 3, that's -5. So I get the exact same points. So you can either get it by drawing and sketching on the chart, or you can get these mathematically. You know, and sometimes you have to have one or the other, you know, depending on the situation. Like if there's fractions involved and that sort of thing, you probably want to go with a more mathematical method in that case. All right, so we have the center of the vertices. We need the foci, which is just the plural of focus. So the foci, these are going to be located a distance of lowercase c away from the center along the major axis. But I don't know what that lowercase c is. But what I can do is use these two to discover its value. So for instance, I know that c squared is equal to a squared minus b squared. So c squared is going to be 9 minus 4 in this case. So c squared is 5, which means c is, generally we would be careful and say plus or minus the square root of 5, but we're going to add and subtract this number from the center anyway. So it is perfectly fine to just estimate it at this point and just say that it's positive square root of 5. Now, to locate that on my chart, I would need to estimate it. So the square root of 5, I would be adding to negative 2. So if we did like negative 2 plus the square root of 5 and negative 2 minus the square root of 5, that gives me the y values associated with those. So basically, the foci are located at negative 4, negative 2, that's my center, but I'm moving the y variable plus or minus the square root of 5. So if I approximate these, they're at the points negative 4 and actually let me just say 0.2, because if I said 0.236, I don't think it could be possibly that accurate on my chart. So 0.2 is about as accurate as I think I could even be. And negative 4, negative 4.2. So I could draw these on my chart here. So negative 4 and 0.2 would be, let's just say right here. And then negative 4 and negative 4.2. There's my other focal point. The last thing that I need to do is provide the lengths of the major and the minor axes. And one thing about that is we know that the distance from the center up to the vertex, we know that distance is a, and we know it's equal to 3. Now, if we went the other direction, so went from the center out to this vertex, this distance would be a, which is 3. The distance all the way across is going to be 2a, which is 6. So the length of the major axis is always going to be double whatever the value a is. So in this case, that's 6. Similarly, the length of the minor axis is just going to be double whatever b is. B was 2. 2 times 2 is 4. Next, identify the location of the center, vertices, foci, and the lengths of the major and minor axes. Afterward, provide a sketch of the ellipse. Same situation, but different ellipse. So let's see what we can do. Starting with the easy stuff, the center is located at 2, negative 3. Now we look at the numbers underneath the x and the y parts of this equation. And whatever the largest one is, that's the value of a squared, and the smaller of the two is b squared. So what that means is, in this case, a is equal to 3, and b is equal to the square root of 8. 8 could be written as 4 times 2, so I can reduce that into 2 square root of 2. Now I have a and b. I could get c from that. Might as well go ahead and do that now. So c squared is going to be a squared minus b squared. That's the formula for ellipses. So c squared in this case is 9 minus 8, and that's equal to 1, which means that c is equal to 1. All right, so my vertices and foci are what I need to come up with next. Foci, pluralize a plural word. That'll make sense. All right, so the vertices. The value of a is underneath the x. So this is going to be an ellipse that is stretched or elongated along the x-axis. So the major axis is horizontal. So my center, which is at 2, -3, it's located right here. When I get the vertices, I'm not going to change the y variable, I'm going to change the x variable. So I would do 2 plus or minus the value of a, which is 3, comma -3, because the y is staying the same. So I guess I should give myself some space to work here. So 2 plus 3 would be 5, and 2 minus 3 is -1. So my vertices are at -1, 3. Whoops, -1, -3. And that's right there. And the other vertex is at 5, -3. There's my other one. The foci, c is equal to 1, so I'm just going to add positive and -1 to the x-coordinate of my center. So 2 plus or minus 1, comma -3. So this would be 3, -3, and 1, -3. So 3, -3, and 1, -3. So there are my focal points. The other thing that I need to include here is the b, the minor axis. So it's 2 √2, and I think what I'll do here is just approximate what that is. So 2 times the square root of 2 is about 2.8. So I need to go about 2.8 away from my center. So this would be 1, 2, 2.8 would be like right here. And then going down, so 1, 2, 2.8 would be there-ish. All right, so now I have all the points that I need to get a decent sketch of my ellipse. So I can draw the sketch of the ellipse. The last thing that I need to provide are the lengths of the major and minor axis. The major axis length, of course, is just double whatever A is. So that's going to be 6 in this case. And the minor axis length is going to be double whatever B is. So 2 square root of 2 times 2 is going to be 4 square root of 2. In this example, we're going to take some properties of an ellipse and come up with an equation for it. So we want to write an equation for the ellipse with the following properties. It doesn't say to sketch it, but it's generally a good idea to kind of locate where the different points are graphically, and that way you can better understand if the major axis is horizontal. It's just generally better to visually see what's happening. So I'll start with sketching some points here. So 2, -2, my center is located there. 7, -2, that is a vertex. And 4, -2 is a focal point. So one thing that I can deduce right away is that the major axis is horizontal. And that's just because the location of the focus that's given and the vertex that's given with relationship to the center point. And from that, the equation that I'm going to use would look like x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So that is the equation that I would be working with. Now I already know what the center point is, so I have h and k to plug in, and I already can get A pretty quickly because I do know that A is the distance from the center to the vertex. And so in this case, A is equal to 1, 2, 3, 4, 5 units. Or I could have taken 7 minus 2 and gotten it that way. But 5 units, that's fine. And then the distance from the center to the focal point, that is lowercase c. And in this case, c is equal to 2. So using those two pieces, I can come up with what b is by solving. Because I know c squared is a squared minus b squared. So c is 2, so c squared is 4. A is 5, so a squared is 25. And then we're going to solve for b squared, so I'll leave that alone. If I subtract 25 from each side, negative 21 is equal to negative b squared. Divide both sides by a negative, they'll become positive. Then take the square root. So I have the square root of 21 is equal to b. So I have everything I need. Now my formula here is going to be x minus 2 quantity squared over something, and I'll get that in a second, plus y plus 2 quantity squared over something equals 1. Now the parts underneath, a I discovered to be 5, so that's going to be 25 under the x value. And then b was the square root of 21, so when I square that, it is just 21. So there's the equation of that ellipse. Next example. Write an equation for the ellipse with the following properties. Vertices at 4, 3 and 4, 9. Focus at 4, 8. So let's plot these points and then see where we can go from there. So 4, 3 is going to be there, so there's a vertex. 4, 9 would be here, there's another vertex. Then we have a focus at 4, 8. Now, the first thing I can deduce here is my major axis is definitely going to be vertical. So when I develop the equation of my ellipse, I'm going to need the x variable first, so x minus h quantity squared over, and I'll write it in that part next, y minus k quantity squared over something equals 1. To get the major axis vertical, the a squared would need to be under the y variable. Alright, now let's see what all I can figure out here. So I don't have the location of the center, but the center is always going to be the midpoint of the vertices or the midpoint of the foci, however you want to look at it. So the center is located at the midpoint of the vertices or the midpoint of the foci, however you want to look at it. It's going to be the same. Since we know where the two vertices are, I'll get the midpoint of those. And to find a midpoint, you're just going to take the average of the x's and the average of the y values. So in this case, it would be 4 plus 4 divided by 2. So 4 and 4 are the x coordinates of the vertices. 3 and 9, so 3 plus 9 divided by 2. My center is going to be at 4, because 4 plus 4 is 8, divided by 2 is 4 again. And 3 plus 9 is 12, divided by 2 is 6. So 4, 6 is my center. Now with that, I can start deriving some other things that are important. Like, for instance, number 1, the distance from the vertex to the center, which would be lowercase a. In this case, it should be 3 units. And there's a multitude of ways I could get that, just counting from the center up to the vertex, or if I take 9 minus 6 or 6 minus 3, either one. That distance is going to be 3. The value of c, which is the distance of the center to the foci, that value is 2. Now what I need to do is calculate what b is. So I don't know that, but I can find it by using the equation c squared equals a squared minus b squared. So c is 2, 2 squared is 4, a is 3, so a squared is 9, minus b squared, so negative 5 equals negative b squared, and divide both sides by negative 1. So we get b is the square root of 5. Now I have all the pieces that I need, and I can just plug right into my formula to get the equation that I need. So x minus 4 quantity squared over something plus y minus 6 quantity squared over something equals 1. So b squared, we just determined that b was equal to the square root of 5, so b squared is 5. And a squared, since a is 3, a squared is 9. And there is the equation of that ellipse. Next up, write an equation for the ellipse with the following properties. The foci are at 5, 1 and negative 1, 1. The length of the major axis is 8. So let's just plot here and get started that way. So 5, 1 is a focal point, and negative 1, 1 is a focal point. The length of the major axis is 8, but until I know where the center is, I don't know that I can really use that right away. So let me get the center. In the center, I can also get the midpoint of the foci as well. So the midpoint here, 5 plus negative 1, which would be 5 minus 1, over 2, and 1 plus 1 divided by 2. That's going to be 5 minus 1 is 4. 4 divided by 2 is 2. 1 plus 1 is 2. Over 2 is 1. So 2, 1 is my center. Now the length of the major axis is 8. And that is equal to 2 times a. So what that means is a is equal to 4. So 4 units on the left and right side of the center would be the location of the vertices. So there's one and there's the other. So a is equal to 4. And then if we look at the distance from the center to the focal point, that gives me c is equal to 3. And using those two pieces together, I can develop what the value of b is. Because c squared is a squared minus b squared. C squared would be 9. A squared would be 16. If I do 9 minus 16, that's going to give me negative 7. So b squared is positive 7, or b is the square root of 7. Now my major axis is horizontal, so I'm going to need to have my a squared underneath the x variable. So when I make up my formula, I'll take care of that. So the center is 2, 1, so this is going to be x minus 2 quantity squared over something, plus y minus 1 quantity squared over something equals 1. So the under the x is going to be the value of a squared, that's going to be 16. And under the y is going to be the value of b squared, which would be 7 in this case.